All right, let's jump right in. We're not looking at some slick, polished marketing video today. Nope, we're actually dropping into a real, authentic training session, kind of like a fly on the wall. We get to see how a team gets up to speed with a powerful VR development toolkit called the Varity SDK and how they learn to build some seriously complex training apps from scratch.
And you know what? This is where it all begins. Not with some mind-blowing feature, but with, well, the real world of being a developer. Before they can even really get started, you hear someone say this: yeah, the thing with Git is still an issue. I mean, if you're a developer, you have definitely been there, right? It's just the perfect hook because it shows that even the coolest, most futuristic projects have to deal with the same old headaches we all do.
And that's the key thing to get here. This isn't some pre-canned presentation. We're listening to an actual live recording of a team getting trained. You can hear them talking about IT problems, people working from home on their own computers, trying to get everything scheduled. It's messy, it's real. And honestly, that's the perfect backdrop for understanding why a toolkit like this even exists in the first place, to solve these exact kinds of real-world problems.
And the goal they have, it's huge. I mean, they're not just learning to make a little app. They need to figure out how to build a full-blown interactive VR training simulation for a really complex piece of industrial hardware, a vehicle launcher to be specific. So yeah, we're not talking about making a simple game here. This is about creating a super detailed, fully functional digital twin, something people can use for serious, effective, and safe training.
Okay, so if you're going to tackle a project that big, you have got to start with the right foundation. And in the VR world today, choosing your development engine, well, that's a massive strategic decision, especially with how fast the hardware scene changes all the time.
And right away in the training, they explain why they went with Unity. Look, Unreal is obviously another incredible option, especially if you're deep into C++. But for them, Unity had one massive advantage: platform independence. The idea that you can build your application once and then push it out to a whole bunch of different devices, that's not just a nice little feature. That is a core part of their entire strategy. And just look at what they're targeting. It's not just one headset. We're talking Meta Quest, Pico headsets, the brand new Apple Vision Pro, and they even mentioned tablets. I mean, just think about that for a second. Each one has its own ecosystem, its own way of doing things, different controllers, or in the case of a tablet, no VR controllers at all. Trying to build a separate native version for every single one of those, it would be an absolute nightmare.
And this quote from the trainer just nails why this is so important. He basically says, we just don't know how things will proceed at the moment. The whole VR market is constantly shifting, right? You've got companies trying to build their own walled gardens. If you get locked into just one of them, you're taking a massive risk. So this idea of platform openness isn't just a preference, it's the bedrock of their whole approach.
All right, so they've picked their platform, but how do you actually build the logic for the training? The step-by-step instructions. This is where we get to the real secret sauce of the Varity SDK. It's all built around this really cool idea called a state engine, which lets you map out super complex stuff without having to write a ton of code.
So what the heck is a state engine? Well, the easiest way to think about it is like a visual flowchart, but for your app's brain. You have states, which is just what's happening at any given moment, like waiting for the user. Then you have transitions. These are the triggers that cause a change, like the user actually clicking a button. The key is, the app can only be in one state at a time, which makes it absolutely perfect for building out structured step-by-step training.
Let's make this real with the example they used in the demo. Okay, step 1. The state engine highlights a flap on the vehicle. That's state 1. The app is now in the highlight flap state. Next, it just waits. It's waiting for the transition, which is the user selecting that flap. As soon as you click it, boom, the system moves to state 2. An animation plays, the highlight goes away, and it's ready for the next instruction. It's this clean, logical flow from step to step, all laid out visually.
And here is the payoff. The trainer flat out says that with this visual approach, something like 90% of the development work becomes just dragging and dropping these logical blocks around. I mean, just think about that. It's a massive time saver, and it means people who aren't necessarily pro-level C# coders can still jump in and build really complex training logic. That's an absolute game changer.
Okay, so the logic is sorted. That's the brain of the operation. But that's only half the battle, right? How do you make the world itself feel, well, interactive? How do you let people actually touch and move things? This is where the SDK gives you a whole toolkit to bring those 3D models to life. Right out of the box, the SDK gives you these pre-built interaction components that cover pretty much anything you'd need.
You've got grabbable for things you can pick up. You've got interactable for stuff that's fixed in place but you can use like a big lever. There's pokeable for buttons and touchscreens, and even scalable for objects you might want to grab with two hands and inspect up close. The best part? You literally just drag and drop these onto your 3D objects, and they just work.
But there's always a but, isn't there? There's this massive sort of hidden challenge that comes with all this cool interactivity, especially on a standalone headset like the Quest, and that challenge is performance. You gotta remember, these headsets are basically smartphones strapped to your face. They don't have unlimited power, so optimizing your application isn't just a good idea, it's everything. It is absolutely critical.
And to give you an idea of how much of a difference this makes, check this out. In the training, they talk about one specific trick. On a single vehicle model, they got rid of complex, real-time shadows and used a simple invisible shadow mesh instead. The result? They saved 100,000 polygons from one change. That is an unbelievable performance boost from just one very clever optimization.
Okay, so everything we've talked about so far has been about a single person in a headset. But that's not always how training works, is it? Sometimes you need people to work together, or even compete. And yep, the SDK is totally ready for that. It's designed to go way beyond just single-player stuff and right into the world of multiplayer.
And it handles both worlds really smoothly. On one hand, you can build that classic single-player, step-by-step training scenario. No problem. But on the other hand, you can use its built-in networking tools, which are based on Unity's own netcode, to create shared virtual spaces. Places where multiple people can be in the training at the same time, see each other's avatars, and work on the same virtual equipment together.
And to really ramp up the engagement, and to actually measure how well people are doing, there's a whole gamification module baked right in. This is super cool. It means developers can easily add things like scoring systems, they can track correct and incorrect steps, give people instant audio or visual feedback, and even make different things happen in the simulation based on how well the user is doing. It basically transforms a simple walkthrough into a real, measurable skill test.
So when you boil it all down, the big story here is really about accessibility. Toolkits like this SDK, with their visual scripting and pre-built components, are just lowering the barrier to creating these incredibly complex and high-value VR applications. And that leaves us with a really fascinating question to think about. As these powerful tools become easier and easier to use, what entirely new forms of training, collaboration, and interaction are just over the horizon?